Okay, so in the last video we talked about what an assessment is. An assessment is a combination of a belief system and behavioral strategies. A belief system tells you, if you're in an information set, which history has occurred with what probability, and a behavioral strategy tells you what action you will play with what probability every time you have the chance to play an action. We also talked about when an assessment is an equilibrium, and that's when the assessment follows sequential rationality and consistency of beliefs. We'll explore that a little further in the context of this game. So in this game, first player 1 moves. Player 1 can take 3 actions. One is C, then D or E. Player 2 doesn't know. Player 2's information sets will either be E. So if E happens, player 2 knows for sure, but it's not her turn. Game ends after E, so there's nothing player 2 can do about it. The other thing that player 2 could learn is that it's either C or D. So the information sets for player 2 are either C, D or E. If CD happens, if one of them happens, then player 2 can choose either F or G, either F or G. In case D happens, then the game ends after player chooses F or G. If C had happened, then if player 2 chose F, player 1 would have the choice between J and K. A belief system here would have to specify for player 2 the probability that C happened versus D happened. And just to concretize things, the example in the book puts a 2/3 weight on this and a 1/3 weight on this, just to begin with, just so that we have some probabilities in mind. We can also use this opportunity to more formally define what sequential rationality means. So, at any point in any game, you will have a beta. Beta here is a profile of behavioral strategies. So it encapsulates, it captures the behavioral strategies chosen by all of the players. So beta I is equal to beta is equal to beta I, beta minus I. Just like we had alpha equal to alpha I, alpha minus I, it's a profile basically for all players. And mu is a belief system. And again, it is the belief system, it captures the beliefs of all players at every time where there is that uncertainty in an information set. And what OII beta mu means is it's the likelihood of different outcomes. It's the probability distributions over different terminal histories that will occur if we start from II and we play a behavioral strategy beta. So that's the profile played by all players under a belief system mu. So if we start at CD and player 2 always chooses F and player 1 chooses J, if we start here and that's the idea, that's the beta and the mu is 2/3, 1/3, then OII would put a weight of 2/3 on this outcome and 1/3 on this outcome, where this is the terminal history and this is the terminal history. And what sequential rationality says is that moves are sequentially rational, so players' behavioral strategies are sequentially rational if, as player I can do no better than choosing beta I as my behavioral strategy. So playing as player 1, I should be able to do no better than playing J if we start from II, and as player 2, I should be able to do no better than F. Right? That's the gamma I here is the set of all other behavioral strategies that I could have chosen. So that's the notion of sequential rationality here. So the thing we want to do is to find an equilibrium now. Okay, so I'll give you guys a moment to start running this away. So how do we find an equilibrium? We use basically the same sort of techniques we used when we were thinking about sub-imperfect equilibria. Right? I'm going to erase this for now. And this, and these green lines. Okay. So let's say as player 2, I think there's a 2/3 chance that player 1 has played D and a 1/3 chance that player 1, 2/3 chance that player 1 has played C and a 1/3 chance that player 1 has played D if I enter this information set. If player 1 is here, faced with these two options where there's really no uncertainty, player 1 would just choose J, earn 3, and player 2 would earn 0. Right? Now given that, let's say player 2 is here, okay? What would player 2 choose? With the probability, if player 2 chooses F, then with the probability 2/3, player 2 earns 0, and with the probability 1/3, player 2 earns 1. So the expected utility of player 2 from playing F is just 1/3. The expected utility of player 2 from playing G, on the other hand, is get 1 here and 0 here. So that's 2/3, right? Because 2/3 times 1 plus 1/3 times 0 is 2/3. So player 2 could play G. And if player 2 is playing G, then player 1, choosing between C, D, and E, is indifferent between choosing either D or E, right? Because player 1 would earn 2 either way. However, we are going to have an issue with this because what are our candidates for equilibrium? And I say candidates because both of them are not going to be equilibrium here. Our candidates are either E, J, G or D, J, G. Right? But if either C or D is ever played, right, then they must be played in some ratio 2/3, 1/3. Otherwise, player 1's beliefs will be wrong. Or at least they must be played in a ratio such that it allows player 2 to continue to play G. Right? And we're not going to be able to do that. We'll show that next. So before we go there, let's just see if EJG works. So this one is the one that's a little questionable at the moment. Let's just see if EJG works. Okay, player 1 always plays E or J when player 1 has the turn to move, and player 2 always plays G and has this belief of 2/3, 1/3. At no point in this equilibrium are we either being irrational sequentially, because player 2 can do no better than play G if this if this information set occurs and she has this belief. Player 1 can do no better at any of its information sets. So sequential rationality is maintained. Consistency of beliefs is also maintained because we never actually, in equilibrium, in the steady state of this game, we never actually arrive at this information set. So player 2's beliefs that if CD happens, if player 2 is told that one of these two things is happening, then C is played 2/3 of the time and D is played 1/3 of the time, that is never actually contradicted. And so beliefs also remain consistent.